Hi everyone. Now today I will be doing a presentation for our operating system project assignment, and our project assignment consists of a C++ program, which aims to illustrate, which aims to stimulate a process, a scenario where a user, whether he or she is a reader or a writer, to access to a public resource or maybe modify the public share file without much conflict. And our program utilizes threads, mutexes, and condition variables to manage data synchronization and also to ensure the data consistency. And for our group, not just only me, Ji Kun, and also consists of my beloved fellow groupmates, which is Aman Fauzi and also Jack Leonardo. So for today, we'll be going through later about our. We will have a simple brief of our code and also the intended outcome of our system, and also we will have like a very quick demo. And for the goal of our project assignment, as I mentioned before, is to simulate the operating system scenario where the user, where the reader or the writer are trying to access or trying to modify the files without many conflict, which means that when a reader is reading, there are no we need to ensure that there's no writer who are writing, and when a writer is writing, there are no reader who are reading to avoid confusion or maybe avoid data inconsistency. Before we start with any function, we have defined a few global variables for synchronization. Now, these global variables are very important because these global variables ensure the data consistency. You keep track of anything, make sure the data is synchronized. And we have defined four of them, which are mutated MTX, condition variable CV, and the integer read count, and the boolean is writing. The mutated MTX is to protect the shared data. The condition variable CV is to like allow the track communication and also to guide the user to go to the intended function. And the read count is to keep track of the amount of read, and of course it's initialized as zero, and the boolean is initialized to false. And this is important to like keep track of, is there any writers who are writing, and we assume that there's no writer writing at the moment at the start beginning of the at the beginning of the system, so we also initialize it as false. Now first, for the first part of our system, we have our read function. Now, when the system start up, we will tell the user that he or she is currently accessing to a file, and we will also get a prompt to have the user to answer whether he or she is a reader of a writer. If he or she is a reader, then he could just simply type R, which indicates that he or she is a user. He's a reader, right? R for reader, right? And then we will show that he or she is a reader. And if by the moment there are no, like let's say writer is allowed, at the start of the system it is always allowed because there are no writer by the moment, then we will allow the user to read the file. And also we will have the mutex on. It locks the mutex to so that there will be no writer could write. And also at the end of the read function, we will increment the read count by one, and we will also show to the user. And because this is like a multi-case scenario, so we will like show we will show that if a writer is writing and the user is a reader and he is trying to read, we will show this scenario in the next slide. And let's say, what if a writer is currently writing a file, and this is the example. What if a writer is currently writing a file? If a writer is currently writing a file before the reader is trying to read, then as we can see on the screen, we will show that to the user that, oh, you are a reader, but reading is not allowed because a writer is writing. And we'll always keep check of with the user whether the writer is done writing. Only if the writer is done writing, only the user is allowed to read to the read to the file. And also we have set a thread function to log, and also we have a timer that will iterate a few times to make sure when is the writer done writing. Only will be allowed for the for the reader to read. Now, for the write function, it is quite similar to the read function. When for firstly, when the system starts up, we will also show the user they are accessing to a file, and we will also get a prompt to ask the user whether he or she is a reader or a writer. And if a user is like a writer, he will definitely input W, right? W that indicates for writer, and we will also the system will also tell them that he or she is a writer. And if there are no other readers, then writing is allowed. But there is a few differences that I will mention in the next slide. Okay. Okay.
Now,
Now,
similarly, if
for the
let's
case
say
if
a
there
writer
are
is
other users
writing
who are using
it's
and or a
unlike
reader is
our
reading,
readers, because
then
when
maybe
there are other readers
like
who are reading,
maybe a reader is
there
reading and you're a
like
writer, you're trying
for
to read,
example, if
then of
user
course
A
it will
he's reading,
we will get the
user B
same
could
output
also
that
read into the
currently
share file. But
currently writing is not
for the write
allowed
function
because
case, it will
there are
be
some readers who
slightly
are reading.
different, even though it
So
is also
we
have
will
the
always
mutex
keep check with
mutex
the
log
user whether
to
is
prevent the
the
readers from
is the
accessing.
is all of the readers
But
done
in this
reading,
case,
and it
it
is
will
done
be
reading,
like
then
more
we will
strict a bit.
proceed.
Remember
We
the
will proceed
boolean
to let the
boolean variable
current writer to
that I
write,
mentioned earlier, the
and
is
also we
right
will always log the
boolean
mutex as
is
usual
also set
to
to be
prevent
true,
interruption from
because
the
it
other
wanted
readers
to
or the
prevent
other
others writers from
writers.
accessing also.
Let's
Now,
say
similarly,
if
let's
as
say
everyone
a writer
can
is
see on the
writing,
demo, this is a case
and or a reader is
where like
reading, then
a writer trying
maybe
to access when a reader
like
is reading, right?
maybe a
Like
reader is reading
if
and
reader
you're a writer,
A
you're trying to
is trying to
read,
read,
then of
writers
course
it
writer
will
C
we will
it
get
cannot
the
be
same
accessed.
output.
But
That
if writer A is
currently
done is
currently writing
done
is not
done
allowed
reading,
because there are some
and
readers who
writer
are
C is
reading.
finally allowed to
So
be processed with
we'll
his
always
writing.
keep check with the
But
user
in
whether
that case, a
the
new writer, writer
is
D,
all of the
he
readers
could
done
not
reading, and if
like
he's done
access to
reading,
the
then we will
access to the file
proceed.
also. He could
We will
not
proceed
modify
to
to the
let
file
the
also.
current writer
This
to
is to
write,
prevent like
and also we will always
the
log the mutex as
concurrent
usual
changes on the
to
files and the
prevent
data.
interruption from the other
So this is
readers
very
or the
important.
other
So we need
writers.
to
Like
now
set
similarly,
this
if
restriction
let's
to
say
prevent
a
like
writer is
conflicts
writing
and confusion.
and or a
So
reader is reading,
let
then
to
maybe
long story short,
like
if a
maybe
writer
a reader is
is
reading
trying
and you're a
to
writer, you're trying to read,
write,
then of course it
and
will
he's in the
get we will
system,
get the
the
same
others
output
reader can't
that
read. This is very
currently straightforward.
currently writing is
And
not allowed because there
others
are some readers
writers
who are
also
reading.
cannot write.
So we will always
Other readers
keep
cannot
check
read,
with
and
the
also the
user whether
others
is
writers
the
cannot write.
only
Is
all
the
of the readers
respective
done
writers
reading.
could write.
And if
That
he's
is
done
the
reading,
case for
then
write
we
function,
will
and
proceed.
there's a main
We will
difference
proceed to let
between
the current writer to write.
the write function and
And
div
also we
function.
will always log the mutex
And
as
the
usual
rest will be the
to
same.
prevent
The
interruption
system
from
will
the other
always
readers
trying
or the
to
other
check
writers.
check with the user
Now,
whether the reader is done
similarly,
writing,
if
the previous
let's
user is
say
done.
a writer is
So yeah,
writing
it's pretty much the same.
and or a reader is reading, and now we will go to the main function. Now, this function is to help the users. Let's say when the user is done with reading and writing, is done with modifying and accessing, and is trying to like exit the system, exit the file. So he could always press E, which indicates exit, right? So our system will show the user to for how long they stay in the program. Like in this case is 1.749 because this is demo, so I just immediately exit, right? So yeah, and also we have this is because this is a continuous prompt, right? So we have already set an auto end function so that it will like auto close the system when reach a certain amount of time. We will record the program runtime from the beginning of the system, and yeah, basically this is like a function to help the user to exit the system. Okay, and then after the exit of the system, it will show the user how long they have used our system, and also display the program's runtime. Okay, now as we promised, we are going to do a demo video about our system. As I mentioned and explained in the few slides ago, the user will be told that they are currently accessing to a file, and will get a prompt from the user whether the user is a reader or a writer. Let's do reader first. Yeah, and the user will get a message about their user and reading aloud, and the mutex is on, and we not because we want to like prevent other writers from writing. Yeah, and okay, that's really very obvious. And let's say we are going to do reader again, and we'll get the same message, just that the read count will be increment again. Yeah, let's say I'm done reading and try writing. Okay, and because I'm done writing now, but currently there are other readers that they are reading, right? So writing is not allowed by the moment, because reading are reading, as in the system's record, right? So we need to make sure that all the readers are done reading, and then we will go here, and then only we will be allowed to like write to the public share resource or the public share file. Yeah, and the system will like keep on repeating to check again if like the writers or the readers are not done. Okay, in this case it's the readers not done, right? So let's say I'm another writer and I'm trying to access to the file. Yeah, because another writer is writing, so I'm not allowed to write. So let's say I know that the other writer is not done writing. So yeah, I'm always not allowed to write because the other writers is still writing, and this process will like repeat for a few times until the other writers are done writing. Yeah, the system will keep Chrome up and to keep track with the user whether is the other writers done writing. Yeah, let's say the other writers is finally done writing, then only I will be allowed to like to write to the public share file or the public share resources. Okay. Let's say I'm the last user. I'm trying to read the file. I'm very slow to all of this. Yeah, and you can see when another writer is writing, readers is also not allowed to read, even though the first two readers, and as we mentioned, as we showed at the first of this demo video, they could read together, but currently as a reader I could not read while somebody is writing. Yeah, and unless they are done writing, only will be I allowed to read the files. Okay, now let's exit the file. Okay, and the system will show because it's been recording our runtime from the start of the system, and it will show that this process exited after 190.087 after you use it, after you start it up. Okay, that's all for my demo video. Now for conclusion, our system illustrates a scenario that uses mutexes, threads, and also condition variables and many more techniques to perform concurrency control and ensuring safe and consistent access to the share file and also share resources. And I'm glad everyone was here with me until now. Now I hope everyone have a good day. Okay, thank you very much.